Yeah, I can hear you.
Okay, thank you so much. I want to welcome everyone to my lecture today. Of course, today the focus is basically going to be on stepwise regression model. Okay, now you remember the other time I promised that today lecture is going to be on the Zoom. And not only that, the topic that I'm actually bringing in today is something that we have done before, except that we haven't done situation where we combine both forward and backward at the same time. You remember as part of variable selection technique that we've done before, I actually walk you through what I call a step where, a forward selection, the backward elimination, but I haven't walked you through how to proceed in both direction. And of course, the topic today, we centered on that. Okay, now, in the outline, we're basically going to focus on, techniques for variable selection. Of course, at times we could have so many predators in a regression model, and we basically want to devise a means of selecting the significant ones. And I remember I walk you through what I call, off subset selection, then the stepwise selection. So the stepwise is what I'm visiting now. And of course, under the stepwise, we have the guided forward, we got the backward and stepwise. Okay, so if you take a look at what I'm trying to show you now, display now, just trying to display technique for variable selection. And of course, there are three techniques, under we have, or let me just say, broadly speaking, we got two of them. We got all possible regression. You remember, or under all possible regression, we consider different kind of subsets and that we can have. And at the end of the day, I remember I walk you through how you're going to figure out the best one predator, the best two predator, the best three predator, and at the end of the day, the best one predator will compete with the best two predator, will compete with the best three predator, depending on the numbers of predator you have, using the criteria that consider module fitness and module complexity, the AIC or the BIC or the adjusted R-square. And of course, under the stepwise regression method, we have the forward, the backward, and the stepwise regression. I remember the other time when you're talking about all possible regressions, of course, if you have k numbers of regressors, of course, the possible numbers of modules you're actually going to have will be 2 raised to power that. Okay, and that's basically going to be a lot. You get what I mean? Okay, so I'm going to walk you through this example, but before I go into this example, I think I need to remind you about how the forward selection work, how the backward elimination work. The forward selection is more or less like you are starting with intercept model and you are adding a significant predator into your model. You actually stop until the optimality condition has been satisfied. Then with a backward elimination, you're basically gonna start with a complicated model, and in a way you're going to be removing the insignificant one, okay, until you actually arrive at the final model. Now And of course, in the stepwise regression is the one that can proceed in both direction. The stepwise regression is just going to tell you, okay, I'm going to be adding significant variable, and at the same time, I'm going to be eliminating insignificant one. So the stepwise regression proceed in both direction. So I'm basically going to use an example here. A hospital surgical unit was interested in predicting survival in patients undergoing a particular type of liver operation. A random selection of 54 patients was available for analysis. And of course, the potential predictors are, the blood clotting score, which we denoted as X1, the prognostic index, which include the age of patient, the enzyme function test score, and the liver function test score. And let me tell you this, how I think we're actually using the knowledge, the domain knowledge, to be able to come out with this predictor. Maybe we actually liaise or collaborate with somebody, an expert in the field, and of course they actually suggested this particular four predators, that could influence, the survivor, okay, in patient or that go in that particular operation. Okay, so but here, of course, the numbers of candidate regressor is small because we only have like 4 of them. Okay, so when you take a look at what I have now, this is generating what we call a scatter plot. Okay, this is a scatter plot matrix, where you basically gonna have a pairwise comparison, the relationship between any two variables. There's something I wanted to pay attention to. The response variable is being logged. Okay, so take a look at that. So maybe they realize that was a issue with a violation, one of the assumption violation. That could be normality, that could be linearity, and so on like that. Of course, maybe probably that was why this was logged in the first place. But the scatter plot that you actually said here actually passing information about what is a likely relationship between any two pairs of variable. Okay, so I want you to take a look at this result that I have now. Okay, now what I'm trying to do now is, okay, um, when we consider, let's first do this. How many do we have here? Let's do the count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Now, when you take a look at what I have now, don't forget 2 raised to power. The numbers of predators initially is actually 4, right? I'm going to take you back, take a look at that. And of course, the possible numbers of modules we basically going to have will be 2 raised to power 4. I think you know that, right? Now, 2 raised to power 4 will basically be 16. And that very 16 will include the intercept module. Okay, as you can see here, the reason why we got 15 here, okay, the intercept module was not part of this show at all. So these are the possible modules that you can actually have when you have the here the method that I'm actually using is what we call the off subset selection, the off subset selection. So take a look at what I have. If you want to combine all of that together, like using the model selection, the criteria I gave the other time, the AIC, the mean square error, because we have different metrics of evaluations. Okay, we have different kind of metrics of evaluation that we can actually use. You get what I mean? So now, when you take a look at, if you want to choose the best model based on the AIC, right? You basically is basically going to be this guy here. Okay, it's going to be this guy here. I just wanted to take note of that. So why is he that guy? Because when you look across, that guy actually have the smallest AIC. And if you also want to use what I call the MSC, which we call the mean square error, okay, the mean square error we always normally use that the mean square error when we take into consideration the variance and the bias. Okay, now the model with the smallest mean square error is the one we're also going to consider. And if you take a look at in the case of the adjusted house squared, okay, you're basically going to see that the model with the highest adjusted house squared is that as well. So the of course I'm not going to talk about the house square. You know, I told you the other time, the moment the numbers of predator is actually more than 3 or from 4, we may not be able to trust the house square. But even though here he's still doing a great job, okay, up to this guy here, okay, only that is also saying that there's no difference between the R squared of this guy and this guy. So like I said, don't focus on the R squared. When we have a good numbers of predator in a model, we basically going to focus on the adjusted R squared, the AIC, the mean square error, and so on like that. So when you look at this across now, you're basically going to see that the best model now, according to the all subset selection using the criteria of the AIC, the MSC, the adjusted R squared, we're actually going to choose this 3. And what are the 3 that we basically going to choose? I need to go back now. You know, the X1, S2, S3, what it's trying to tell us is that, okay, if I really want to predict the survivor in patient undergoing a particular type of liver operation, then I should, you know, the predator variables, you know, the best predator variable should be this guy here. Okay, which means we need to consider the blood clotting score, the prognostic index, and the enzyme function test score. Okay, so which means by off subset selection, it's trying to tell us that X4, which is a liver function test score, is not really important. Okay, so that is what that is actually talking about. So using the idea of off subset selection now, that's what we come out with. Okay, now at the end of the day, the final model is basically, the main function of the final model is basically going to be this guy here. I need everyone to confirm again if you are still hearing me clearly. Are you still hearing me clearly?
Yeah, I can hear you.
Okay, thank you so much. Okay, I also want to hear from other participants. You can talk or you can shout or you can give a thumbs up if you are hearing me clearly. So is everyone hearing me clearly now? Okay, good job. Thank you so much for confirming that. Okay, so I want to go into stepwise regression method now. We have look at the of subset selection, and of course, we came out with you know, a final model, you know, that consider X1, X2, X3. Don't forget, well, we started with the 4 predator. Now, looking at the stepwise regression method, of course, we've done this in class. We're basically going to consider the 4 selection, the backward elimination, and the stepwise regression. Let's go into the forward selection. Now, we of course in the forward selection, we're basically going to begin with no regressor at all, which means we're actually starting with nothing. We're starting with an intercept, and we're basically going to check model with all possible regressors added individually. And of course, in the next step, we had the regressor that more changes the criteria in the correction direction. Okay, of course, the criteria that we may do forward selection with the AIC, we may do forward selection with BIC, we may do forward selection with the adjusted R squared, and of course, we're actually going to arrive at the final model if none of the regressors have a positive effect on your criterion. And we're actually going to start with the regressor you have, and that is basically going to be your final model. Of course, I demonstrated that in class manually. Okay, now I'm going to go into the data now. Okay, we're still using the same data set. Okay, don't forget using the subset selection out of 4 predator. Of course, the subset selection only selected 3 predator to be part of the final model. But right now, we basically want to see how the forward selection, we want to see whether the forward selection is basically going to select different predator. Of course, this is how to do it in R. It's another way to do it in R. I think I've already walked you through how to demonstrate that in R. This is the output, and at the end of the day, you're going to see what it select. Okay, now the forward selection actually uh, selected uh, everything. Okay, the forward selection actually selected everything. Okay, it selected the X1, the X2, the X3, the X4. But if you take a look at the S4, even though it selected you know, all the predator. If you take a look at the p-value associated, okay, with the X4 here, of course, it's not significant. Take a look at that. Okay, so the fact that the forward selection actually selects a predator does not mean that at the end of the day, the predator will be significant. It doesn't mean at all. You get what I mean? So, but of course, the only way to tell, okay, is just to look at the p-value associated with that. So the forward selection we're using here actually use the minimum AIC. Okay, so take a look at that. The forward selection selected X1, X2, X3, X4, so which means actually select all of that. Okay, so now we've seen what the forward selection does. We're going to go into backward elimination now. Like I said, I've explained this in class, but I'm just trying to go over this now for you to be able to understand the stepwise regression that I actually want to showcase today. Now, with a backward elimination, we're basically going to start with a complicated model. Like, for instance, if we have 10 predators, we're actually going to start with all of that. We're going to start with all predators that we have. And of course, we're going to be dropping the predator. Okay, we're actually going to be dropping the predator that improve your selection criteria the least. Okay, and we're going to continue until there's no predator that can be dropped anymore. Of course, and result in an improvement of your selection criterion. And of course, then the other remaining predator we actually be selected will be part of the final model. Okay, I wanted to take note of that. Okay, so this is another way to run, backward elimination is to use the idea of drop. Okay, drop one of that. So at the end of the day, let's see the result. Oh my god, the backward elimination also selected X1, X2, X3, and you can now see between the off subset selection and the backward elimination now, based on this particular data set, they actually selected X1, X2, X3. Okay, although if you take a look at the forward selection, selected X1, S2, S3, S4, but the X4 was not significant. You get what I mean? So take a look at this one now. Before I move forward, is there anyone who want to ask question?
I do have a question. I might have missed this from previous lectures, but is this backward elimination dependent on the order the variables are sorted in? Like, could it be that like a variable that's later down the list is more significant than one that's earlier, or vice versa?
Oh, that's a very good question. This is what happened. In class, I walk you through something that we call an algorithm or something like look like a shard, the idea behind the backward elimination is just like if I have four predators, I'm actually going to start with the four. Now, when I start with the four, the step one is I'm actually going to run the regression, okay, using all the predator, and I'm actually going to get the AIC for that particular model. And the next step is basically, I'm going to look at the, after having all the four predator, of course, the next step is going to be having three predators. Okay, you're gonna go from having four to having three, and when I say three, you're going to consider there's going to be three possible numbers of threes that you can have out of four. Just like the way I demonstrated that in class. It could be x1, s2, s3. It could be x1, s2, x4. It could be x1, x3, x4. I think you can check my notes in class when I was showing one particular algorithm where I started from the most complicated, using the highest numbers of predator. Then I'm actually going to be going down, like in this case now, when I got four, then I'm going to go to three. Then after three, I'm actually going to go to two. And after two, I'm going to go to one predator. And after one predator, I'm actually going to go to intercept. Okay. So I think I've already demonstrated that. But let me tell you this, the way it appears now, whether you have x3 first, x2 for or s2 second, or x1 third, it doesn't really matter. You get what I mean? So I can have x1, s2, s3. The fact that I have three of them in the model, okay, the fact I have x1, s2, s3, it doesn't matter about the way it is arranged. It is the same. Does that make sense to you now?
Yes, thank you.
You're welcome. Okay, now as you can see here now, the three predators selected by the backward elimination is actually significant, judging by the p-value. Oh my God. I want to go to something new now. In class, I mentioned stepwise regression, the one that can proceed in both directions, but I didn't really, clarify on that. And of course, I want to use the same on this particular data set now. Okay, so this is the code. If I really want to do that, I'm actually going to use step AIC. Okay, step AIC into my model. You get what I mean? So take a look at what I have now. Okay, so the moment you use that on the data set, you get what I mean? We say using the same data set, right? Okay, the moment you actually do that, it's going to take a lot. Let me tell you the way this guy works. Okay, it's going to add some significant variable. It's going to delete or eliminate insignificant. One is doing that. At the same time, you can see it got a lot of result, right? But at the end of the day, we basically going to see the one is select. Oh my God. Take a look at this guy now. It's actually selecting X1, X2, X3 as well. So which means there is a kind of agreement now between stepwise regression, the backward, and the off subset one. Well, if you look at the forward one selected all of that, but in the end, when you take a look at the p-value associated with that, of course, it was not significant. But I'm actually going to say on this particular data set now, it's like all of them, they are in agreement in a way. Okay, they are in agreement in a way. So I just wanted to take notes of that. Okay, so I'm actually having a comment here, comment on stepwise regression techniques in general. The techniques we have discussed in these lectures are all quantitative, computational, and therefore have many scientific drawbacks. Let me tell you this. There's no approach that we use in this world that doesn't have, limitation. Don't forget all models have assumptions. And of course, there's possibility, you know, we could the model could miss the best you know, it could, I mean, the approach could actually miss or skip the best model, okay, but the far remain they really working good, okay. So because it's a computational, and of course there could be scientific drawback, okay. This is not peculiar to the approach we're using, but the approach of science in general, okay. Now, they should never replace careful scientific thoughts and consideration in model building. Okay. And how do this technique fit in with our scientific examination of precision variables and confounders? Don't forget, when I talk about confounders, more or less like reason why we may want to consider, maybe you're looking at the effect of one particular variable, the variable of interest on the response, and we realized that we needed to adjust another particular variable that may influence the relationship between the two variables under investigation. And how should we treat influential observation in a stepwise selection setting? Don't forget, when you are dealing with a stepwise selection setting, you got to make sure that you don't have anything that has to do with outlier. Every other conventional assumptions of ordinary linear regression has to be met as well. You get what I mean? So take note of that. Okay, go ahead. I think somebody raised hand. Yeah, go ahead. Yeah.
Professor, sorry if I missed this in the previous lectures, but how do we select which technique of variable selection do we have to use? Like, is there any particular scenario where we'll have to use forward selection and particular scenario where we could use stepwise selection?
Okay. That's a very good question. In this particular data, you can say that I have to do all of them. You get what I mean? It is necessary that if we can just do all of them, like let us say those ones that agree. You saw what happened in the agreement between the forward the agreement between the up subset and the backwards selection. In fact, the agreement occurred between all of them. On average, let me tell you this, on average, they're basically gonna agree. You get what I mean? But I mentioned something the other time about backward elimination should not be used when the number of observation is less than the numbers of predictor. I mentioned that in class. So, and that's why it's better we also need to read a note on them on each of these stepwise selection technique. Okay, so we need to first identify situation on that way. Like backward elimination is not appropriate when the number of observation is less than the numbers of predictor. But here now, of course, the numbers of observation is more than the numbers of predictor. We can use all of that, and let's say the one that agree, depending on your data set. So you're basically going to see that there's an agreement between all of them here. I don't know whether if I've answered your question.
Yes, Professor, you've answered my question. Just a follow-up question on that. So, in the case when the number of observations are less than the number of predictors, should we also not use stepwise regression because it is also a combination of backward?
And that is the reason why the method you're actually going to use, like me, when the numbers of observation is less than the numbers of predictor, it's better not to even consider these at all, any of these at all. You go for ridge regression or the lasso regression that we did. Does that make sense?
Yeah, that makes sense, Professor. Thank you.
I love statistics because anytime there's a kind of challenge, there's always going to see, we're always going to have a way out. And that's why we have other technique as well. Okay, so I think I just demonstrated to you now. Now I put further example here. Further example, let's take a look at this. Somebody is looking at the effect of weight and height. I mean, weight and maybe, let me see. Yeah, the weight, age, skin fold, fatty acid. You get what I mean? The fatty acid is actually the response here. Okay, using the backward elimination now. This is what we have, and the final, the model selected is actually this guy here. So which means if I want to talk about the fatty acid stuff, okay, initially we have this predators, age, weight, skin food, but the backward elimination now actually selected just age and weight. Okay, so I just wanted to take note of that. Okay, now when we go into a different one, when you go by the way of the forward now using the same data, as you can see here, the forward is going to start with an intercept model. Don't forget about that, right? Okay, so let's say what that one is going to select. Okay, let's say the final module. Okay, the final module now, you can see they agree. Look at two of them agree now, right? Okay, that one also select the weight and age. Okay, that also select the weight and age. Take a look at that. Okay, now by the time we now move to something else, now give me 1 second. When you now consider the one that proceed in both direction. I just wanted to see the difference between the code. You see both here, right? Both. Okay, instead of forward, backward, you basically just indicate both. Okay, of course, you're basically gonna see result associated with that. So in the code, it's just like for backward, you in the direction you put backward, for forward in the direction you put forward, for both in the direction you put both. You get what I mean? So that is what you basically going to do as far as that is concerned. Okay, so then I think this also selects the same. Okay, I didn't display the result, also select the same. So is there any question for me today? Because this is going to be the end of my lecture today. Is there any question? Let me say before I go today, I'm actually going to release practical 3 rubrics today. Okay, I'm actually going to release that. Currently, I'm grading assignment 2, and of course, Monday, we basically going to meet. I wanted to make sure you enjoy your Thanksgiving break. Stay safe. Okay. Uh, is there anyone want to ask question before I go today? Is there anyone? Okay, so I want to thank everyone for attending my lecture. I hope you enjoying that until Monday. That I'm actually going to come your way with another fantastic topic in statistics. Just like what I used to say, statistics is more or less like a story that goes on and on and on and on. So make sure you enjoy your Thanksgiving week. Bye for now, everyone.
Thank you.
You're welcome.
Thank you. Happy Thanksgiving.
And you too. Yeah.